Okay, a trigonometric equation here, and quite a tricky one, not least because it's got squared things in, so that is suggesting to me it's a quadratic. Also, it's a mixture of sine and cosine, and that is my first problem. And to deal with this thing, I'm going to use a very popular, very commonly used identity. And that identity is that the sine squared plus the cosine squared of an angle will always, whatever the angle, give me 1. And knowing that, I also know that rearranging the sine squared of an angle will be 1 minus the cosine squared of an angle. And I'm going to use that identity in here so that I can switch from sine squared to cosine squared, and hopefully then I will be home and dry. I will be able to sort this thing out. So we have 2 cosine squared of theta, our angle, minus cosine, minus 1 equals, and let me use my identity to switch now. So instead of sine squared, I've got 1 minus cosine squared. Quadratic, so it must equal 0 if we're going to try and solve this. And let's rearrange. We have 3 cosine squared minus cosine minus 2. Now at this point, many people, having spotted it's quadratic, want to just make life a little easier. So if we stop thinking about cosine for a minute and just think about a quadratic, that's what we're looking at. And quadratics, we can use the quadratic formula, but hopefully we will be able to factorise, do this slightly more easily. 3c and c it's got to be, and 2, well, I'm thinking this way around, so I get minus 3c plus 2c, and that will give me my combination of factors to give me that. And this is going to be 0 when the factors are 0, in other words when c equals minus 2/3, or when c equals 1. Excellent, nearly done. So, thinking now back to our cosines, we have 2 options. The c, in other words the cosine of theta, could be minus 2/3, or the cosine of theta could be 1. Let's deal with the cosine of theta could be 1 first. If we've got any idea what the graph of cosine looks like, which is like that, then we will know that it equals 1 at 0 and 360. And so 0 will have 360 is excluded, and so we don't need to put that. So 0 is one of our solutions, and over to this one, theta equals minus 2/3. I think I'm going to need my calculator to sort this one out. So inverse cosine of minus 2/3 and see what we get. 131.8. Let's go back. So one of the angles that my calculator is telling me is 131.8. The whole thing's symmetrical and you can see it from a graph, or we can have a look at our circle, 90, 180, 270 back to the start, and 131 somewhere in here, which means that we've got to consider our other angles. So 131, which is this one, and cosine positive, all positive, sine positive, tangent positive, and my cosine here, note, is negative. Cosine negative happens in 2 of the quadrants, this one and this one. And so what I'm looking for is I've got my 131.8 here, and by symmetry the other angle I want is 360 minus this 131 there. So my second solution is 360 minus 131.8, and so my second solution is going to be 228.2. So three answers. Theta equals 0, theta could be 131.8, or theta could be 228.2. And we have solved our equation.